I'm back, and here is a periodic table of elements. But what I recommend that you do is go to the internet and find a periodic table of elements, or find one in a textbook and have it next to you as I'm lecturing over this material, because I'm going to be kind of flip-flopping back to this picture, but it's a whole lot easier if you've got your own periodic table of elements in front of you, and then you can look at it. So this is the periodic table of elements. Now notice it's got a funny looking shape. So you might be wondering, why does the periodic table of elements, why does it stick up on the sides? And then also, why has it got a separate part that goes underneath it like that? Well, there's a specific reason for that, and we are going to discuss that. So the first thing that you got to notice when you go to the periodic table of elements is every element has two numbers. And you'll notice that one number does not have a decimal point, and then the other one does. So what we want to do is concentrate on the number that doesn't have the decimal point. So that's going to be called the atomic number, and that's going to be the number of protons in that particular element. So now let's go back to our periodic table here and look at hydrogen, and you'll see that hydrogen has a 1. It has an atomic number of 1. It's got 1 proton. So that means every hydrogen in the known universe, if you were to grab it, it's got 1 proton in its nucleus. Now, we didn't say anything about the neutrons, so that's a different story. So we're just going to be talking about the number that doesn't have the decimal point, which is the number of protons. Now look at helium. Helium's got a 2. So how many protons has it got? 2 protons. So every helium in the known universe has only 2 protons in its nucleus. So you'll notice that every element in the periodic table has a unique atomic number. The number of protons, that's what determines the identity of the element. Okay, now let's look. Now incidentally, the number that does have the decimal point, that's going to be called the atomic mass. And that takes into account the number of neutrons that are in there. So we'll get back to that later. So let's now go down and talk about the electrons. So we said that the electrons are in orbit around the nucleus. They form a cloud around the nucleus, but again, it's a lot easier just to think of them making rings going around the nucleus. So most elements want to be electrically neutral. That's really good, because now let's go back to hydrogen. Hydrogen has how many protons? 1, and those are positive. So what does hydrogen need to balance those positive protons? Electrons. So if hydrogen has 1 proton, how many electrons does it need in order to be electrically neutral? 1. Okay, helium's got 2 protons, so how many electrons does it need to balance it? 2. Okay, so this is good, because now when you look at that number that doesn't have the decimal point, not only is that the number of protons, but it's also the total number of electrons that that particular atom has. Okay, so you should be able to do that on the exam. If I give you the name of an element, and I'll even point it out to you on the exam, so you'll have your periodic table, and you can find the element, and the question could be, how many protons does it have? That's the atomic number. Or I could say, how many total electrons does it have? And that's also the atomic number, if it's electrically neutral. Now, we could knock one of those electrons off. So you notice there's sodium, neutral sodium has all of those electrons, and let's say that we hit it with a hammer, or we heat it up, or we hit it with light, but somehow we give one of those electrons so much energy that it pops off and it leaves that atom. Okay, now it takes away with it negativity because electrons are negative, so what's left over is going to be positive. So we say that we have ionized the sodium, and so that is going to be a sodium plus. Now what about if we knocked off 2 electrons? Then what would sodium become? Okay, then since each electron is negative, it would then become sodium plus 2. Okay, and again, it would be an ion. So a ion is a atom that either it's missing electrons, but we could also add an electron to an atom. So again, let's look at sodium, and let's pretend that we add an extra electron to sodium. What would it become? Then it would be sodium minus, because that extra electron has negativity, and then we would say it's a negative ion. So some atoms naturally want to be positive ions, and then other atoms naturally want to become negative ions. And we'll see examples of that in just a few moments. All right, let's take a break, and when we come back, we're going to talk about where do the electrons live inside the atom.